Okay. Yes.
Is it okay now, sir?
Yes, it's okay. You wrote a story actually. I don't know. Okay. Go ahead.
Okay, sir.
What happened, Ghazanfar?
No, sir. I am just want to turn on the camera. So is it
Yeah, let me check you are on the camera or not. Yes, we have to see the face of the person from Sindh.
so now I am in Islamabad?
Yeah, but you have genes from Sindh.
Oh,
Sai,
okay.
hurry up, Sai.
Yes, yes. Sir. Okay. Give me 1 minute. Sir, can you see now the
Yes,
presentation?
yes, I can see even before I was seeing.
I don't know where is the.
Make it full screen.
Is it
I
in
think yes. I
full
mean,
or
it's not full. Yeah, last time it was full, but again, no. I
okay?
think
Okay.
the person who can show their face much better to show because it's a good gesture.
And now it's full screen, I think.
Yes, a full screen. Start now.
Okay, okay. So, firstly, I will introduce the article which we are working on. Uh, the main article which we are following is the title has the simulation and experimental design of locking amplifier based on the multisim. So, first, I will discuss the overview of the article. So, the main question arises: what is the lock-in amplifier? So lock-in amplifier is an instrument which is used to extract the small or useful signal which is buried inside the noise. So this technique is actually based on the phase sensitive detection. So in this article we have the four main components which we are dealing. One is the signal channel, second is the reference channel, third one is the phase sensitive detector, which is the main component of the lock-in amplifier, and last is the low pass filter. So I will discuss briefly about these four channels, which are what kind of help they are doing in this article. Firstly, the signal channel. This channel is actually the input of the modulated signal, which we are giving to some kind of signal which is buried inside the noise. So this signal is maybe sinusoidal or triangular or square waveform. So the second is the reference channel. In this channel, we generate the signal which is coherent to the modulated signal. And this signal may be also in form of the sine, square, or triangular form. So the third component is the phase sensitive detector. In this detector, we have give these two input signal and reference signal, which is demodulated them, and this demodulated signal will appear as our output signal. So then this output signal is passed through the low pass filter, which filter out the demodulated signal having the high frequency component. So this is the block diagram of the lock-in amplifier. As we discussed, these have the four main components. One is the inputs signal channel, the reference channel, and the phase sensitive detection and the low pass filter. So firstly, I will discuss the input signal channel. We successfully simulated the input signal channel. In first, we have the pre-amplified circuit, which we have to get the 2% gain, two times gain. This next is the band pass filter, in which we get the gain of the 11 times, and the cutoff frequency which we are required is the 900 to 1100. So the last one is the instrumental amplifier circuit, which have the gain of the 100 uh, times. So the total gain of the input signal channel is about 2200 times. When we multiply all these gains, then we get this 22 times, 2200 times total gain of the whole input channel signal. And then we have the phase sensitive circuit. I didn't simulate this, but I find uh, this circuit from another article, which will I will definitely try to simulate this thing also. So these both signals are then passed through the phase sensitive detector, where they multiplied, and we get the our uh, our coherent input signal, which we have desired which we wanted to get input signal from first place. So then this signal is passed through the low pass filter, where it attenuate the high pass frequency component, and then we pass this to the amplifier to amplify the signal which is buried inside it. So this is the simulation work using the multisim. This is the first component, is the preamplifier. As you see, this is the circuit diagram in which we have the two operation amplifiers, and these the respective resistance are connected. So on the this left side, right side, we have the function generator, which is operating around 1 kilohertz, and having the initial input voltage about 1 millivolt. So this is the oscilloscope. As you show this waveform, this red waveform is the output signal, and this black is the our input signal. As you see, we get the 2 times gain from this input signal from this oscilloscope. The black one have the one scale is the one division, one voltage per division, and also the channel B is also set on the 1 volt per division. So it is clear that we get the 2 times again. So, so this second is the band pass filter. As you see, this is the combination of the resistance and the capacitor and the operation amplifier. So this is the oscilloscope, which shows the waveform. In this case, the channel A is set on the 1 volt per division, and channel B is set on the 10 volt per division. The black one is the our input signal, and the red is the our output signal. As you can see, the channel 1 is the 1 volt is our input, and the channel B is set on the 10 volt per division. So it's almost 11 volt per division, and we get the almost 11 times again. And the frequency which we allowed is the 900 to 1100 hertz. I didn't
Zanfar,
mention.
Zanfar, sorry
Yes,
to interrupt you.
yes,
How many slides do you have?
sir. I have five.
Okay. Because I was thinking, because Adnan Sami's light will be off. So if we give him first chance and then after that you continue, is it okay?
Okay, sir. No problem.
Yeah, sorry for that actually. Because Sami
No
was,
problem.
wait a bit, let me, I mean, if he listens or not. Sami, are you there? Sami, Adnan Sami. Mudassar, you are there?
Yes, sir, I'm here.
You can hear me?
Yes, sir.
Then what's the problem with the Sami?
Maybe he has some problem with his mic or something. I don't know.
He could send the message. He didn't say anything.
Just
Okay,
let
I
him.
mean,
Let
Ghazanfar, you
him
complete.
speak.
Carry
Yeah.
on. Ghazanfar, carry on.
So the last component is the instrumental amplifier. In this instrumental amplifier, we have the combination of the three op-amp and the resistor. So in this, we have to get the almost 100 times the gain of the signal. So on the oscilloscope, you uh, can see easily from the waveform. The black is the wave of the input signal, and the red one is the our output signal. The channel A is set uh, for the 1 milliwatt per division, and the channel B is set at 100 division per division. So it is clear that we have successfully achieved the 100 time amplification. Okay, this is the reference channel, which is the phase shifting circuit. First question arises why we need this phase shifting circuit. Actually, when we are doing the amplification to our input signal, there is some kind of the wave shift uh, to our input signal. So uh, we want these the wave which we want the uh, signal which is coherent to our phase. So we have to design this circuit. So to phase a line between the input signal and the reference signal, that's why we need this circuit. And this will help us to maximize the sensitivity of for the phase and for phase sensitive matching, which will give us the good results. So
Okay, now,
yes,
yes, continue. What's the problem?
I don't know. I have missed some slides.
Missing?
One more slide. Yes, I have one more slide, but it's not there.
Okay, so how many in the block? Go to the block diagram. So how many?
Yes,
Yeah, so how many parts actually you have completed? How many? Like pre-amplified circuit is done,
yes. Preamplifier,
band
band
pass
pass filter.
and
Yes, instrumental amplifier
amplified
is also
circuit.
done.
Okay,
Yes,
and
phase sensitive shifting is circuit is also. I find some
mhm,
of article, so
okay,
I've just to design on the multisim. I didn't do this, but I will do
okay.
maybe this week.
And how do you combine this PSD?
Sir, this actually the article which we are referencing with is the actually the experimental work
Hmm.
they have done.
Okay,
So we have to find something. It's actually the modulator. So I am looking for modulator which is available on the multisim so that we can use instead of this.
okay. So
Yes.
I mean,
So
face, yeah,
band pass filter is also done. I didn't mention here, but we have done some work on this. So
low pass filter, and the
yes, low
amplifier.
pass amplifier is simple. We will
Hmm.
make this one.
So it's
That
mean
one.
80% you have done.
Yes, 80% almost.
Hmm.
But we have to think how we can incorporate the noise signal by ourselves, because that is the main purpose. So we have
Yes,
to look
this
into
is the
that.
main problem which I am
But
also working on
in the
this.
beginning, you can just add the noise by some means. Even you can
Yeah,
use the signal generator.
yes, a small amplitude and
Yes,
with the same
and see, and
frequency.
after that we can think about it.
Yeah, we will see. First, we just now I've been waiting for him. So once he finalize the phase shifting circuit, then we will see how to incorporate the basically noise before going to the low pass filter, because it basically filter out the noise. So before that we
Yes.
have to think of the noises, so we will see that.
Mhm. Yeah, so noise circuit, I mean, you don't need to, I mean, you can just test using any like signal generator
Yeah,
and just
sine
see
wave
how
or
it
something.
behaves.
uh,
Okay, Ghazanfar.
Okay, okay, sir.
So it's, I think you are going okay, but little bit slow. So
Uh,
probably
s-
if you can speed up a bit.
yes,
but
sir. You know the condition. I
Mm-hmm.
have no laptop for past 2 weeks, so that's
Mm-hmm.
why.
you didn't get the laptop yet.
No, I get no. I
Mm-hmm.
have no laptop.
Okay.
Okay.
So it's good,
Just
at least
think,
you got it.
yeah, just think of the noise, how to incorporate, but where to incorporate and how to merge that with the signal. Just think about that and then let me know as well. I'm a little bit confused about that, where to incorporate the noise and how, so that it get mixed with the signal
Okay, okay, okay.
like
Sure.
in phase, so we can remove it clearly. Let me know
Mhm.
that.
Yes, yes,
We
sure.
will see that.
Mhm. Okay, that's good, Ghazanfar. I hope you will be a little bit more active. So,
Inshallah, sir.
yeah. So you have another task, but I'm not asking now. You know that.
Yes, sir.
So maybe if you can work parallel something, and if you can.
So, sir, just sir, first I want to finish this work.
Okay, finish
It's
it.
been
Okay, finish it. I
very,
mean, it's
very good.
lingering on, so you can wind it up. I mean, within one, two
Yes,
weeks,
there is
wind up.
no, also there is no, yes, there is no link between which we are working on and
Mhm.
this part.
Mhm, mhm, mhm. Okay, okay. And what is the status of your article, by the way? Submitted one.
Sir,
They are sending you the messages. Why
there is,
they send all the people, all the authors?
That's was the problem. Even though I submitted that, but they always send him in the mail. So I did
Mhm,
not get that.
mhm,
What
mhm,
is that? What's that problem basically?
mhm,
Usually this thing never not happen. Who submitted that, he
mhm.
received the email mostly.
But Mudassar, why don't you want to show your face?
But I'm a little bit health wise not good today. Flu and this and that, so not
So
in a
flu will
good
spread
shape
in
today.
this way through net.
Yeah, I afraid, and I don't want Ghazanfar to take an excuse so that he will
Uh-huh.
not do work for
Mhm,
2 3 days more. That's why I'm a
Okay.
little
From
bit
your
cautious.
side, can you, Mudassar, please send it to the message to Nabil if he's coming or not?
I will
I don't
tell
know.
him.
Khadpan, so, Bahrain.
Maybe he is not online. I will see.
Yes, but you can just send. I mean, his reply is okay. If not, then.
No.
So Adnan Sami, I think you are sleeping or what exactly? Adnan, what is this really? I mean, if he came, he should reply to me. He sent a message. Adnan, you are there? Okay. So if Adnan is not replying, so let's move to Aqsa. Aqsa, are you there? Or you left? Yeah, Aqsa is here.
Assalamu alaikum, sir.
Walaikum assalam.
Assalamu alaikum, everyone.
Walaikum
Yes,
salam.
sir.
Yeah.
Walaikum
So
salam.
so you are a new team member. So can you please introduce yourself now? This is the first thing you're supposed to do.
Sir, please describe content or main heading so that I will explain accordingly my education
Yes, yes.
and
I mean,
my
like,
job experience.
yes. I mean, starting from your name, your education, and your experiences and your expertise and etc. I mean, whatever you want to say about you.
Yes, sir. As everyone knows, my name is Aqsa Khalid. I'm from Faisalabad. Um, I have completed my master's and MPhil education from University of Agriculture, Faisalabad. So during my MPhil studies, I was appointed as a research associate in AHEC funded project. So after my completion of MPhil degree, up till now, I'm working as a visiting lecturer in physics. at University of Agriculture, Faisalabad. Basically, my expertise are laser-based spectroscopic techniques such as LIBS, laser-induced fluorescence, and it's a combination of laser matter interaction, laser physics, and materials science. During my MPhil studies, I have worked on laser-assisted synthesis of nanomaterials. Then definitely I will characterize. I have characterized that materials. So my expertise are multidisciplinary: laser physics, laser matter interaction, materials science, and now I am learning about different AI tools or AI programs such as Python, MATLAB. So I think this is my introduction.
So actually, I mean, so what exactly you are doing in these days? You are doing any kind of research, or what exactly?
Uh, Basically, these days I have received some invited book chapters from editors. So
Mhm,
I'm completing that.
mhm,
Uh, I have also written a review article
mhm,
based on my MPhil and afterwards
mhm.
research work. Uh,
Okay.
Now I will complete, but I am going to complete and will submit that review article to any reputed journals.
Mhm,
In some of the journals, I have submitted that, but but that topic is not relevant to that journal, so
mhm.
they
Okay.
refused. I'm trying to submit in somewhere some journals.
Mhm.
Uh, and
Okay.
Also writing some book chapters, and also in search of some all other opportunities for publications or for research work or technical skills or simulations or something else.
Okay. So how
I'm
do you
in a
see?
learning phase.
Okay, good. So how do you see yourself in this team or in this group?
So I think it's a golden opportunity at this phase. Both of my objectives and team's objectives are same. So
Mhm,
I'm also in a search of a team so that I can because when I'm writing book chapters or when I'm writing review articles or when I'm reading different articles, different ideas that came into my mind. So I need a mentor. I was needed a teacher to whom or a team with those people I can discuss these ideas and we can perform work on that ideas.
mhm.
So that's why I need a team with I can work and I can also perform that research work and publish papers and learn something.
Okay. So, and what kind of book chapter you are writing? I mean, what is topic or what exactly theme of this chapter?
Basically, those chapters are on luminescence and material science, and applications are relevant to the biomedical physics.
Mhm, mhm.
Yes, sir.
Okay. So, I mean, if you see, I mean, you're more like a laser application side. And the thing in this team, if you see, we are more like towards the hardware kind of stuff. But still, you can fit yourself here, and you have to figure it out. And how can you contribute in this team and in this group? And what kind of tasks are suitable to you, other than writing and these kind of things. And one more thing, I mean, if you like, I mean, like the outreach, the possibility, this platform will also provide, uh, uh, I mean, can facilitate this platform if some of the people are interested in outreach activities. So, like, it can be some kind of lecture, some kind of uh, sessions, introductory sessions on some kind of unique ideas, or some kind of can be a research idea, can be any software tools, can be hardware tools, or some short lecture series, or this kind of. things can also be done from this platform. So, Aqsa, you may have this opportunity as well, this outreach. You can expose yourself and prove yourself somehow. And other things you can see, I mean, if you want to involve any of these kind of projects, what we are working now, okay, you can see on my webpage as well, that virtual laser lab, laser group. And basically it's some ZMAX stuff and some ultra fast, which Ghazanfar will do. And Mustafa is still new as well, Shoaib Mustafa, but he will also be more like towards more like hardcore. Can be a coder, can be a other hardware kind of stuff. And David actually is from Mexico. At the moment, he's working on ZMAX, but he may be involved in some other matters as well. So this is the things. And thank you very much for joining this group. And I hope you will keep in touch.
Assalamu alaikum, sir.
Wa alaikum assalam. Sami, just a minute. Just give me 1 second. So, Akhtar, so thanks, and hopefully you will be in this group. Keep in touch with all the group members, and probably you can contribute. And if you need any kind of help from the team members, they will be happy to help. Yeah. So thank you very much, Aksa.
Thank you so much, sir, for this.
You're welcome. Okay, so now Adnan Sami is here, and he's going to try if he can present something. So actually, Adnan, he's going to present his master thesis, which he worked ComSet, I think. So Adnan, I mean, a brief introduction of yourself, and then you can start. Adnan. Adnan Sami. Adnan, your net is really, I mean, having a big problem. I don't know where you are in the university.
Sir, at university, right? But the university is using some. I am unable to universities.
No, actually, Adnan, we cannot hear you properly. So I don't know. You can present or something like this, but try.
Okay, sir. I think I can try for next time.
No, try. Now I can hear you. Let's see.
Sir, can you see the screen?
Yes,
right
yes,
now?
yes. We can see.
So let me introduce myself. My name is Muhammad Adnan Sami, and I did my Master's of Science in Physics from ComSet University, Islamabad. And I did my 16 years of education from University of Lahore, where I achieved a gold medal because of academic excellence. And nowadays I am working as a lecturer in the Department of Physics, the University of Lahore Sargodha campus. I have some where I have some additional charges, including as a departmental coordinator, synopsis scrutiny committee member, and department research committee member. Here are some details about me. Proceed forward.
Yes, move.
Here are the outcomes published in toward today's topic presentation is of pulse laser boost propulsion by irradiating a metal target with a nanosecond laser. So I would like to start topic with the quote of well-known scientist Stephen Hawking. Just he said that for human race to survival on this planet, uh, only possible, not possible for 1,000 years. We have to spread out into space for the of human being. So and explore. So the only process we can do for the propulsion. So propulsion is basically derived from two Latin words, pro and peller. Pro means forward and peller means to drive. So basically propulsion is an action of pushing something or some object to drive forward. So the main principle behind propulsion is Newton's third law of motion. We can say that every action has a reaction. We can explain Newton's third law of motion by using equation F is equal to m dot Vex, where F is basically thrust and m dot is the rate of mass expelled from our spacecraft and Vex is the exhaust velocity. So nowadays, basically, space propulsion is enabled by three different systems. So we have a very well-known system, which is chemical propulsion system. Second is electrical propulsion system, and is photonic space propulsion system. So let me introduce about chemical system. Chemical propulsion system, as we all know very well that the chemical propulsion systems are those propulsion systems in which we use chemicals like fuels, usually burning or oxidizing fuel, to propel our spacecraft. There are some limitations in these types of chemical propulsion systems. First of all, thrust to mass ratio. These systems have very high thrust to mass ratios. These systems have very low exhaust velocities, which are which is approximately 5,000 meter per second for the best available fuels. And if I talk about specific impulse, and these systems have relatively low specific impulse. And if we talk about photonic propulsion systems basically uses photons or light to propel a spacecraft. So as these systems use light, so we can also call them laser propulsion systems because we also use powerful laser systems to propel different objects in space. So basically this idea was proposed by Arthur Cantorowitz in 1972. What he said that in space we have an abundant source of free electromagnetic radiations, light. So by using this free source of electromagnetic radiation, we can propel our spacecraft. So these systems have some limitations. As we discussed earlier, thrust to mass ratio. These systems have very low thrust to mass ratios. If we talk about exhaust velocities, these systems have very high exhaust velocities, approximately equals to speed of light. And if we talk about specific impulse, these systems have relatively large specific impulse. So basically, specific systems are also known as laser propulsion systems. So there are two types of propulsion systems. As we're familiar that two is a continuous wave system in which we use lasers are continuous wave laser propulsion systems, and pulse lasers are known as basically the thrust is generated about laser propulsion with it ability the targets and then they introduce plasma. So in the result of plasma expansion produced. Why would laser propulsion using pulse laser propulsion systems? Because they have
Sami,
hospitals
Sami, your presentation
and
is
they
your presentation is frozen.
hello.
Yes, Sami. Yes, continue, Sami.
Sorry, sir.
Yeah, I mean the net is
Okay, sir.
yeah.
So if I talk about why using pulse laser propulsion, so basic, so last point, propulsion systems by using systems we can travel to Mars and 20 means that there is a way to get to 3. So NASA is targeting by using
Sami, your net is really we
they
cannot
already
Sami, your net Sami, we cannot
so
hear.
of
You can reschedule it because
Yeah.
it is very noisy kind. We cannot understand what he is saying.
So, Adnan Sami, your presentation
Get a
is very
call.
interesting, but we cannot hear you. Sami, can you reply?
He has some net issues, so we can
Yeah.
maybe schedule it some other day because it is good, but we are not getting anything what he is saying. It's no use.
Assalamu alaikum, sir. Sorry, I think because of internet I cannot proceed.
Yes, your presentation is very interesting. I want to listen actually, but your net problem. So reschedule or choose a time when your net will be fine. So what do you think, Adnan?
Sir, whenever you will said I will be here. Next time,
Problem net.
inshallah, I will. Today I contacted to the IT office almost 5 times regarding this issue because I was trying to access this app from around 2 p.m.
Okay.
But I think they are unable to fix this issue. So
But it shouldn't be
inshallah.
because of the app, because it clearly shows that the net issue.
Sir, basically, I am using mobile data, not
Okay.
university's internet, because they are using some proxies. We have given some
Okay.
limited access from the university net.
Okay. That could be the reason. So
Yeah.
how will you solve the problem next time?
Next time, there are some. I will try to reach out to the main officer, IT officer.
Yeah,
Okay.
it's really interesting actually. your presentation, and definitely all the team members, they would like to listen to you. And so probably let me know so we can reschedule.
Okay,
And
sir.
I want to ask many things from you as well. So, but it will only be possible if the net is okay.
Sure, sir.
Yeah.
Sure.
So thank you very much, Adnan. So hopefully see you in
Thank
the
you very
next
much, sir.
meeting or something, whenever you let me know. Okay?
Sir, always available, inshallah.
Okay.
Next time.
Thanks a lot.
Thank you very much to you too.
Yeah, you're welcome. Okay, so David, you can stay and you can listen to what other people are saying. Adnan, it's up to you, man.
Yeah, sure. Very
Okay.
interesting.
Yeah, David, can you please start your stuff?
In this case, I was searching for some stuff, another different approach.
No, last time you showed something. You didn't proceed further.
Yeah, I don't go through there, but I was trying to do another attempt instead of having a
David,
diffraction.
David, what we start, we have to conclude something. So, okay, in every meeting, if we new kind of idea is coming, but what we started with the LIDAR in the ZMAX, we have to conclude something. Okay, so that we can move forward. So this is the purpose of this group. Otherwise, to showing new things each and every time, it's useless. So today Mudassar is here, so he could guide you much better than because last time he wasn't here. So at least you can open your last time's presentation here, or your ZMAX, what you have done. So let's involve the Mudassar in it and to conclude something to move forward.
Okay, and let me.
Yeah. You opened the ZMAX file actually last time. Your ZMAX, if I remember correctly.
It will be okay as long as he show me the layout.
Yeah, this was the last time I was trying to achieve this.
Yeah, but what you are getting at the screen actually, what was that? The pattern was not properly what you were showing in the last.
Yes, in the last I was trying to get that pattern.
It has to be like this, but it's not like this. What you are getting.
Okay. Okay, what was in the? I think that was I was trying to replicate some of the tutorials. Boot and the other stuff. And I was trying to achieve this cross diffraction gradient, and
that when we come out with the 2D differential grading, basically what we up till now I have worked, when we you can say define the grating, it's usually worked, you can say, what I can say like that. It is a, like you can say, a single, not a single slit, it's a line. So we will get the diffraction from everywhere. The picture you are showing, it's a 2D. It's a single 2D. You can say a two lines creating this kind of pattern. You can say two rulings
Yes.
like that, something. But in Zmax, if you want this kind of stuff, uh, I think you need to put two grating at a, and one will be rotated at a 90-degree, then you can maybe then you can get this kind of pattern. I'm not sure. I have to see how to define only a two grating, two-dimensional grating with only two rulings, line, you can say, a two, only a two, you can say, straight line.
But
Yes.
This one,
And
David, listen to me. Last time you were showing you don't find that file, that
sorry,
Gmax file.
I cannot find the file
okay, it's okay.
currently.
So you want to simulate that thing you are showing now at the screen?
Yes, I was trying. This was my another attempt, but I don't finish the job. I was trying instead of having a diffraction graded with a pattern, I was going to try to simulate an array of Gaussian beams, and then only a simple diffraction grading, and we have the pattern similar to the that was trying to achieve. But in this case, it's for a vessel, BCL array of Gaussian. Like in this case, some leaders have this multimode BC cell solution that is an array of diodes or laser diodes. In this case, it's similar to have the pattern that I show you last in the presentation in this like this. But in this case, instead of having a diffraction graded with that form, we try to simulate an array of Gaussian beams in, yeah, we're going to have like a matrix in X direction and Y direction. And in this case, only a simple diffraction grading, we can try to achieve this pattern similar to the another pattern, but I don't
Okay.
finish.
So
Okay.
you are saying you are just taking the array of 2D array of, you can say, sources, 2D array of sources. Let's take it
Yes,
that, like laser sources 2D array. Then you want to just put it on a grating and you want to create this kind of pattern. Okay.
yes, yes,
Now in the PPT file, the previous one in which you are showing the some similar kind of this kind of pattern, whether you get that by yourself or that is from some literature, the other file you have just opened before that.
That is from literature.
That is for, okay. So you want to get this kind of pattern, but you did not get that up till now. Okay.
up till now.
Yeah,
Okay.
yeah, this is the thing.
Okay. Okay, I will try that and I will let you know that. The one, this one you are trying, this is our single slit and it will not work the way. It will give you the fringes according to the laser source. If you are using a rectangular source, then it will give you a fringes like this straight one. If you make it circular and if the source is diverging, you will get a circular fringes. So you, and if you want to make these fringes perfect, you have to play a little bit with the, you can say, alignment or a tiltation, because in actual scenario, we usually think that if the path length of the two arms in case of interferometer, it will be give us this, you can say, a fringe pattern, but that is not true, because when the light pass through a component like a lens, if the path little bit deviated, so one beam is traveling more or less than the other one, so we have to tilt the splitter not exactly by 45-degree, by 45.002 degree or something like that, then we get the perfect fringes. That's why here you are getting the fringes, because the weak one, because you are just taking it as a ideal condition. So it is not in an ideal condition right now. The beam is traveling little bit more or less as it more than it seems. So you have to tilt the grating, or you have to do little bit, you can say, play with the source positions or orientation. So you will get the perfect fringes like we have get in our tutorial.
Yes.
And the 2D array, for the lidar, you are trying to making a 2D array of sources. I will try that and I will show you next meeting if I get that pattern as well. I hope we will get that because it is not that much hard, but I will let you know when I will do it.
Oh, okay. Thank you.
Welcome.
Okay, so
I
Okay.
did this. Sorry.
Okay.
Sorry. No. Is this this is for? I think for another.
Okay.
Okay.
Something else.
Sorry. I don't find the last
Okay, it's
the
okay.
last file.
It's okay.
Okay.
We have find
okay,
what you want to do, so you can try that with a 2D array. I will also try it, and then we will next meeting we will see how we proceed
Yes.
with it.
yeah. Mudassar, you can also
Yeah.
see in the last meeting, actually, it's recorded there. So in
Yeah,
the
I will
recording,
go through that.
yeah, you can
Yeah.
see that one. At that time, Nabil suggested him something.
Okay, I
So
will see
you
that.
can go through.
Okay, sir.
So I think lidar is getting pretty slow, the progress. So, but
As I
anyway,
said,
mhm, yeah.
unless I get the exact layout, I cannot do anything. Like now he
Mhm,
told me what he is doing, so I will try that from my side.
mhm,
So it will get faster.
mhm, mhm.
So
So
if I
yeah, you can try to see the last meeting actually.
yes, I
So
will see
that
that.
would help. Okay, so
Okay, sir.
Shoaib Mustafa, I mean, did you do what I asked you to do?
Yes, sir. I am actually compiling it right now, but I'm finding it hard. What kind of information I should put in there because most of my information is just background stuff.
Mhm.
So working with Galvos, the actual working of it is just going to span like 2-3 pages. So I'm not sure if it can reach 20 pages.
Okay, try to make it. I mean, like you need to add something else as well. I mean, like 15, at least 15 pages. Don't go to 20. 10 to 15 pages will be enough.
Right, right. Okay,
And
okay.
yeah, and also I listened your that YouTube which you shared me. It's very
Yes.
interesting actually. But how did you make that one?
That was with Notebook LM. It was from Google. You just
Okay.
upload the document and it creates a conversation and you can ask it questions and it will be a personal AI that will strictly follow the documents you provide instead
Mhm,
of
mhm,
going on to his
mhm,
own
mhm.
hallucinations and
Okay.
internet stuff. So it will
Mhm.
just stick to that.
Okay, so Mustafa, how many you are in practice with the Python now?
Right now, I haven't worked with it recently, but I
Mhm,
have worked on it extensively, like 2-3 years ago.
mhm.
I can revise it in like two,
Mhm,
3 days. It's
mhm.
not that difficult,
Yeah, I mean,
but depends on what kind of thing
yeah,
you want
yeah,
to do.
yeah. I was thinking, but I will talk to you. I mean, maybe in private or maybe I will
Yeah,
feel.
sure, sir.
So probably anyone else. I mean, if something is needed to add in this meeting, otherwise we don't need the next.
Sir, I do have a question. I mean, there's just 1 minute
Yeah,
left, but I can ask it in the group chat maybe. No problem.
you can ask now. I mean, if we
Yeah.
can we can extend the meeting. No problem. I already shared that.
Yes, so I was going to ask about the presentation that they shared, and the problem with the noise. Are they doing it on a simulated, environment, or do they have hardware working with it? Because
No,
I might
it's
have a solution for that.
yeah, Mustafa. It's a purely simulation at the moment.
Yeah, so adding noise is not going to be problem. So a noise is just randomly generated things. So if you have a system where it can accept a digital source of like wave, and wave is nothing else than oscillating values of highest and lowest. So you can create an array of values, and